Hello, folks. You're probably looking at this little worksheet thinking, she already did this yesterday. But that's not true. Today is exciting day 2 of learning about the unit circle. And yesterday we talked about filling in the radians and degrees. I'm not going to do that on here because it's going to get too messy. So we'll look at that when we get to phase 2 of this exciting video. What we are going to talk about is, okay, once I know where I'm supposed to go on this circle, what am I looking for? And we're going to be looking for sine values, cosine values, and tangent values. So those tie back to right triangles. So you're probably asking yourself, how does a right triangle have anything to do with a circle or vice versa? So I'm here to tell you. Keep in mind that this is the unit circle. So the radius, like we talked about yesterday, equals 1. That means the length of every one of these lines, since they're all radii, fancy term for radiuses, they're all 1. So every time we get to one of those spots, they're going to form a triangle, and I'll show you how. And because we only did increments of 60s, 30s, and 45s, they tie back to those special triangles that you learned in geometry and then we relearned here in Algebra 2. And those are finally getting put into place with the unit circle, which will carry over into pre-calc and then ultimately in calculus. And so we're kind of starting to put some of those pieces together. So if you remember with these, the short side is always some number. The hypotenuse is always 2 times that number. And then the long leg is that number times the square root of 3. So in our triangles, for example, to get to this first spot, if I dropped straight down like how we would normally get someplace on the coordinate plane, we'd start at the origin, we'd go over a certain amount, call that x, we'd go up a certain amount, call that y, and then we would get to this coordinate. We would have coordinates x and y. What we're trying to do is transition that into some trig values. That's going to be a right angle. This, I only went up 30 degrees, and so you can see that this triangle is the same as the one I'm using to get to that first spot on the unit circle. Okay, so how does that turn into numbers? Well, if 2n is the one side, this side's going to be half of that. So that means that in this triangle, since I'm using the unit circle, just going to get rid of those, this is going to be 1/2 because this is some number and this is 2 times that number. So far so good. This side, the long leg, has to be this value again, the n value, times root 3. So 1/2 times root 3 turns into root 3 over 2. So these are going to be really key values for us because they're saying that to get to this spot, if you don't want to go that direction, if you don't want to go 30 degrees out like that, you would go over the length of the long leg, which is going to be root 3 over 2, and that's the longest you can go without hitting the edge. So you'd go over root 3 over 2, that would be my x value, and then up this amount, which would be 1/2. Now, keeping in mind that this is a 1, if you went back to what we learned about SOHCAHTOA, and you were looking at what is the cosine of that 30-degree mark. In this triangle, it would be the adjacent, which would be root 3 over 2, over the hypotenuse, which would just be over 1. So the cosine of 30 degrees is root 3 over 2, straight up. If I asked for the sine at 30 degrees, remember I'd be looking for the opposite over hypotenuse, which would be this, because this would be my opposite side. This was my adjacent, and this is my hypotenuse. But because it's a unit circle, I'd be taking opposite of 1/2, putting it over a hypotenuse of 1. 1/2 over 1 is just going to be 1/2. So those values should seem really super duper familiar because they're right here. So what we want to start learning is that with the unit circle, once you get to a location, if you need the cosine of that value, you're going to be looking at the x coordinate. because that is going to be the adjacent side. And you're always going to be putting it over 1. When you're looking for the sine, you're going to be looking at the y coordinate, because that's going to be your opposite side, which is y, the up and down, over your hypotenuse, which is 1. So once we get these coordinates and I'm asked for the cosine or the sine at a certain location, I just have to remember that they're really asking for the x coordinate with the cosine or the y coordinate for the sine. And we will talk about tangent in a bit. Now, the triangles repeat themselves. Like this triangle is exactly the same as this one right below it in terms of size and shape. The only difference is I'm still going out root 3 over 3 as an, root 3 over 2 as an x, but now I'm going down the same distance I went up. So my y coordinate, and therefore my sine at that spot, is negative 1/2. If you remember from yesterday, that spot is 330 degrees, or 11 pi over 6. So a question might read, what is the cosine of 11 pi over 6? So you go to that location, and cosine's asking for the x, so your answer would be root 3 over 2. If it said, what is the sine of 330? You'd go to that location, and the sine is your second value, so negative 1/2. You can kind of remember it a couple of different ways. We've always called these coordinates x and y. Now they're going to be cosine and sine. So you can remember that a couple ways. You can remember that x comes before y in the alphabet, c comes before s in the alphabet. If you really like alliteration, you can remember that sine comes second, however you do that. Well, that triangle right here is exactly the same size and shape as this one across from it. In fact, like I get a little bow tie if I drop down here, and all 4 of those triangles are the exact same size and shape. But here, if I went to this marking, which if you remember from yesterday was 5 pi over 6, or 150 degrees, I would be going back that length. And so my coordinate for x is actually a negative in this quadrant. So my cosine is negative. But then I'd be going up the same amount as up here, which was 1/2. So I kind of think of these as like long, medium, and small. And so far I'm only dealing with the longest one. I went over long, up a short. So the short ones are 1/2, the long ones are root 3 over 2, just like here, the long leg and the short leg. So here I went back a long, so negative root 3 over 2, up a short. Here, I'm still going back that same distance, so this is going to be negative root 3 over 2, but now I'm going down the same y distance, so negative 1/2. So in this quadrant, quadrant 3, both my cosine and my sine are negative. So by knowing this one in quadrant 1, I can find all of these in this first kind of same space where I'm going the same distance over and up. It's just changing directions, back, up, back and down, forward and down. So this middle one is not a 30 or a 60, but if I took this triangle and turned it on its end, now I'd be looking at the same kind of thing, but my short end would be here and my long leg would be up here. So to get to this mark, which is my 60-degree mark, I'm only going over the short leg because now the 60-degree angle is in this corner. So I'm going to the right, the short leg, and then up the long leg. So all these high points are going to create the same triangle. But here I'd be going back the short leg and then up the long leg. So in this quadrant, everything is positive, sine and cosine. Here, the x's are negative to get into that quadrant, which you've known since, I don't know, elementary school. So that's still the case. My cosine would be negative in that quadrant. Okay, then what about this mark down here? I'm going back the same little short leg and down a long leg. So that one's going to be back a short leg, down, a long leg. And then here, same exact triangle, over the short and then down the long. So a positive 1/2 because I went to the right, and then a negative √3/2 because I went down that longer distance. So I only have a few left to mark in. These, keep in mind, are at the very ends. There's no such thing as a corner of a circle, but I find myself using that term, like this right corner or right end of the circle. You went one over and you didn't go up or down. To get to here, you didn't go right or left, you just went one up. So in this spot, the cosine is 1, the sine is 0. Up here, cosine is 0, sine is 1. To get here, I went -1 and then I didn't go up or down. So cosine value -1, sine value 0. At the bottom, I went straight down. So I didn't go right or left, -1 down. So my cosine, my cosine would be 0, my sine would be -1. So the only ones left out are those middle marks. We always leave the middle marks out, but we get to them eventually. They're going to be this guy, because to get to that middle space, you have to go past the short leg, but not all the way to the long, and then up the same distance, because you're going at a 45-degree angle, just like here. So you're going over and up. Now, flashback to the fun days of learning the 45-45, where we learned that this is the same as that, and then this side is that number times the square root of 2. So this one's a doozy, because to get back from here to here, I have to take this value, which is 1, and since that's equal to n times the square root of 2, and I'm trying to solve for n, I'm going to need to divide by √2. So I divide here, and that's easy peasy because that cancels out. But now these values are apparently 1 over √2, but I can't leave them like that. So I have to rationalize those. So after all that work, what I've learned is that in this setup where the hypotenuse is 1, because the hypotenuse is part of this unit circle, so that length is a 1, each of these sides to go over and up will be the same, and they're both going to be √2 over 2. So all of my middle marks in every quadrant are going to have these coordinates, √2 over 2 for both the cosine, which is the x, and the sine. You went over and up the same amount. So to get to that point here, I'm going back and up. So it's going to be -√2 over 2 and then a positive √2 over 2. Here, I'm going to be going back and down, same distances. So -√2 over 2, positive √2 over 2. And on the last one over here, I went over and down. So positive √2 over 2. Oops, sorry, these should have both been negative. And then I'm going to go down, so it's going to be negative √2 over 2. So when it's all said and done, I have this whole unit circle filled in, but why? What's the point? Well, the point is going to be to find trig values relatively quickly. So if they say cosine 3 pi fourths, this is asking you to go here and then find this. So I learned yesterday where that 3 pi over fourths is, and then I'm learning today that this for cosine is an x. So I would go to my 3 pi over fourths, which is right here, middle mark in quadrant 2. And now that I'm there, it's asking me for the cosine, so the coordinate that's in the x spot. So the answer to this question is -2 over 2. What if it asked me for the sine of 270 degrees? Well, I use my markings from yesterday with my new coordinates. I know that 270 is at the bottom, so I'm looking at these coordinates. So this is looking for the y value at that spot. So the y value is -1. So this, once you have your unit circle complete, this is really just an eyeball activity. You go to the correct spot and you find the correct thing. So the only thing that's messy, and I haven't talked about, and I saved this for your grand finale, you're welcome, is if the cosine is going to be the x coordinate and the sine is going to be the y, how am I going to find the tangent? Well, the tangent, if you think back to these triangles, is going to be the opposite over the adjacent. So in terms of that, opposite over adjacent in our picture is going to be the y over the x. And so this one can get kind of messy, but again, there's patterns to it. So once I establish some patterns in my unit circle, I'm going to use those a lot more than having to think. Like kids look at this and go, how am I supposed to memorize that? Well, you're not. Like look at some of the patterns as you count your way up. Every single coordinate is over 2, so that part's not challenging. If I look at my x's, the top goes √3, √2, 1. So it basically counts down 3, 2, 1. And if I go over, on my way back down, 3, 2, 1. So there's a lot of ways you can kind of start to look and find patterns. That will happen with tangent values as well. So these two are pretty easy. I just have to look at the circle. But this one can be a little tricky because let's say they asked me for the tangent of 30 degrees. So that's my first spot. Well, I would have to take my y, which is a half, over the x. So I'd have it over √3 over 2. And then I would have to do what we learned with stacked fractions. I'd have to take the top times the reciprocal of the bottom. These would cancel. Now I have 1 over √3, but I have to rationalize that. So finally, I end up with the fact that my tangent would be √3 over regular 3 at that spot. So tangent can take a little bit of doing. What if it wanted me to find the tangent at pi? Well, I go to pi, and it's tangent, so I take my y, which is 0, over my x, which is 1, and in that case, I get 0. So the tangent of pi is 0. Now, what about something like the tangent of 315 degrees? So 315 is over here. This looks like it's going to be quite dreadful. I'm going to take my y over my x, but it doesn't matter how messy this is. Anything over itself cancels out to be a 1, but I still have a negative. So the tangent at 315 is -1. So it seems like an awful lot. You want to be able to practice filling in your unit circle. Once you have quadrant 1, you're going to notice that everything else in the quadrant is the same. It's just a matter of what's plus and what's minus. So for example, here I know my middle is √2 over 2, √2 over 2. So are all the other middle marks. It's just a question of what pieces are positive, what pieces are negative. All right, that is probably a lot of information for one day. Hopefully you were able to take that in and it's good enough to help you get through that portion of the homework. If you need a little refresher on how to fill in these radians and degrees, you could go back and do that. If you want to practice on your unit circle from yesterday, here I went over long, up short, √3 over 2, 1/2. This is a middle, so I went medium, medium. This one I went over the short leg but up the long leg. So 1/2 √3 over 2. Or again, as you count, you can go 3, 2, 1, 3, 2, 1. Always over 2. The only ones that are different are these edges. 1, 0, 0, 1, -1, 0, 0, -1. And now your coordinates are really just going to be repetitive. Here up at the top, they'll be the same here. The only difference is I went negative to get into this quadrant for an x and positive to get up high. This one, all of these that are like at the very top and the very bottom will have that same coordinate. So this one's going to be now negative, negative. So negative 1/2, negative root 3/2. Same thing straight down here. I went over the same amount and down the same amount, but a positive x direction, negative y. All my middles will have this exact same thing. So root 2 over 2, root 2 over 2, but to get into this quadrant, my x has to be negative. Middle mark here, root 2 over 2, root 2 over 2, but to get into this quadrant, they both have to be negative. Here, my middle mark, root 2 over 2, root 2 over 2, but to get into this quadrant, positive x, negative y. All right, how about the low riders down here at the bottom? Root 3 over 2 and 1/2. So over here, root 3 over 2 and 1/2, but this one was a negative x, positive y. That's a giant negative sign. Here, going negative root 3 over 2 and then down that half. Here, I'm going over root 3 over 2, down that half. So root 3 over 2 is positive, the 1/2 is negative. So now I can again, like, what's the cosine of 60? Well, I go to 60, then I remember that cosine is x, so I pick 1/2. I feel like you're experts. Hopefully, if not, hop into a WebEx, ask me some questions, watch a video again, chat with your friends. Make sure you're asking questions because this is good stuff that you're going to need to know later. And I want you to feel confident about it. So have a great morning, afternoon, evening, middle of the night, whenever you're watching this video. Bye-bye.